Imagine deleting your database, stripping out all your API calls, removing something like 75% of your files.
That's terrifying.
Right. But ending up with a system that is infinitely more robust than what you started with. Welcome to today's deep dive, where we are doing a forensic audit of a code base that did exactly that.
Yeah, it was a radical transformation. It really challenges almost everything we are taught about enterprise software architecture. And just to set the ground rules right away for you listening, this is a pure technical audit.
No selling today?
Exactly. No selling. We are taking a calm, factual look at real searchable code captured from live runs.
So if you've ever tried to pull apart a monolithic application, do you know how quickly things get messy? We are looking at two distinct worlds today. The first world is labeled 0-1 before.
Right.
And this is a cashier system, the kind that has been written and in production for years.
And we really should emphasize that it worked perfectly fine in production. The second world we will look at is called O2 Puppet. This is the exact same cashier system, executing the exact same business requirements, but after a fundamental paradigm shift in how the code is structured.
So let's start by unpacking that 0-1 before world, because I think any developer listening will instantly recognize it. You open the domain project and you see a 22-file starting point.
Very standard.
Yeah. And on paper, it looks like a model citizen. It's got everything we're told makes, clean code.
Yeah.
Everything is injected via interfaces. It's fully async. The logging is comprehensive.
Yeah.
Any senior engineer would probably approve the pull request without a second thought.
Well, on a surface level, yes, it ticks all the boxes of modern dependency injection and solid principles.
Right.
But dependency injection can sometimes act as camouflage. It hides the fact that the underlying structure is completely entangled.
It's like buying a house where the living room looks perfectly decorated. But if you look closely, the plumbing and the electrical wires are inextricably sewn directly into the sofa cushions.
That is a great way to put it.
You can't move the couch without bursting a water main.
Yeah.
If we look at this one specific method in the audit, the invoice async method, the illusion of clean code completely falls apart.
Yeah, when you look at the mechanics of invoice async, it is trying to manage three entirely different business domains simultaneously. You've got sales, warehouse, and accounting.
It's a lot.
But the real structural damage isn't just the mixing of domains. Woven between those domain rules are 6 completely distinct I/O call sites.
Let's actually list those out for you because it's staggering when you see it all in one single method. You've got the log statement, a REST call for bank authorization, a MySQL save to persist the cart,
Right.
an HTTP status return, and 2 separate print commands. 6 I/O operations woven straight into the business logic.
And the fatal flaw there is that HTTP status.
Oh, absolutely.
The moment your core domain logic computes an answer and returns HTTP 400 bad request, it ceases to be a pure business program. It is now permanently welded to the web.
It's trapped. You can't just lift that business logic and drop it into, say, a background worker or a native desktop app, because a desktop app has no concept of an HTTP 400.
Exactly. You'd have to drag the entire ASP.NET web framework along with it just to calculate a shopping cart.
It's crazy.
And these structural sins, they bleed directly into the method signatures themselves. Look at how the domains interact. The warehouse object takes the entire cart object as a parameter, reaches inside it, and pulls out the lines to iterate through the inventory.
Which seems completely backwards. I mean, why is the warehouse dissecting a shopping cart?
Right. The vocabulary itself reveals the flaw. A cart is sales vocabulary. So if the warehouse requires a cart to function, the warehouse now strictly depends on the sales domain.
But sales obviously has to depend on the warehouse, because you can't complete a sale without checking if the inventory exists.
Exactly.
So sales calls warehouse, and warehouse requires sales.
Yeah.
You have just created a fatal, inescapable dependency cycle.
And what's fascinating here is how developers usually react.
Yeah, I see this all the time. The immediate developer instinct, the one we've all had, is to just refactor it. You see the tangled mess and you think, I'll just separate these into 3 clean, isolated DLLs: sales, warehouse, and accounting.
Which brings us to folder 99 in this code audit.
Ah, folder 99.
Folder 99 is basically the body left in plain sight. It documents this exact refactoring attempt, and it is an attempt that fails spectacularly.
Yeah, if you try to force those projects apart into separate DLLs, the build instantly dies.
Yeah.
It doesn't even make it to the compiler. You get hit with that dreaded MSB 4006 build error. Circular dependency detected.
You don't have to debate whether the dependency cycle is a theoretical problem. You can run the code in folder 99 and watch MSB 4006 stop you dead in your tracks.
Right.
But here's the truly fascinating part. Let's say you cheat. Let's say you somehow use interfaces to hack the compiler and force those three domains apart, stripping out all the I/O.
You end up with pure logic, but completely useless logic.
Okay.
Because nobody can run it. There is no main method, no endpoint, nothing saves to a database, and nothing prints a receipt.
Precisely. The moment you try to actually wire it up to run in production, the domain absorbs all that I/O back in. The database injects itself into the cart, the REST client injects itself into the checkout.
And you are sent right back to the 22-file mess you started with. You can't solve an architectural flaw with just dependency injection.
You really can't.
Okay, let's unpack this O2 puppet world, because the audit presents a solution to this trapped, cyclical nightmare, and it involves putting a new box right in the middle of everything called the Cashier puppet.
Right.
Now, looking at this setup, my first instinct as an architect is to call this an orchestrator pattern. It's sitting in the middle, telling sales, warehouse, and accounting what to do. How is this any different from like a standard API gateway or a Saga pattern orchestrator?
It's a very common initial reaction, but they are fundamentally different mechanisms. To orchestrate is to coordinate things that remain many. An orchestrator manages separate, independent services and tries to keep them in sync. The Cashier puppet does not coordinate separate entities. It is a character with its own state and verbs, and crucially, it has absolutely zero I/O.
Wait, stop. A Cashier system with zero I/O. How does it actually do anything? You can't just pretend the network doesn't exist when you need to charge a credit card.
Well, it doesn't pretend the network doesn't exist. It simply refuses to execute the network call itself. The Cashier puppet creates a composite that enters history as a single atomic act. It authors a verb. When it acts, it executes a check against the rules, prepares the cart, commits the stock, deducts the stock, posts the ledger, and yields the print data. It constitutes one complete act entirely in memory.
And that check mechanism is doing some heavy lifting there, isn't it? It's not just receiving a true or false Boolean from some external payment gateway.
No, not at all. The check actually computes. It evaluates against the internal price list. It looks at, say, items 1, 2, and 3, and asks the domain exactly what those items are worth in that exact moment. It binds the external bank's authorization strictly to those specific items, not the inventory itself. But it never makes the HTTP call. It just defines the rules of the authorization.
Looking at this mechanical shift, putting this author in the middle, it actually reminds me of the genesis of object-oriented programming.
Oh, really? How so?
Well, back in the procedural days, if you wanted to update inventory, you'd write a standalone function like commit stock, and you would pass in the warehouse data and the cart data as parameters.
Right, you'd feed the state into the function.
Yeah, and the entire OOP revolution wasn't some massive rewrite of Boolean logic. It was a mechanical shift. They took that first parameter, the warehouse, and moved it to the left of the dot. It became warehouse.commitStock.
Ah, I see.
It was a tiny syntax move, but it completely revolutionized how we model behavior.
That is a brilliant parallel. The Cashier puppet shift relies on an equally small mechanical move. It's not about moving the noun to the left of the dot. It's about putting an author in the middle of the domains. Paradigms are made of these small, deliberate moves. You stop asking domains to authorize things they don't understand, and you give that authority to a specific actor.
So when we introduce this actor, this Cashier puppet, what actually happens to our code base? Let's look at the survival rate of that 22-file monolith we started with.
The complexity just evaporates.
It really does. Those 22 files drop down to exactly 5 survivors.
Just 5 files remain to define the entire clean domain. You have warehouse, ledger entries, cart, price list, and sales.
It's hard to believe until you actually see it. But what really caught my eye isn't the C# files. It's the project file. If you open the csproj file for this new domain, it is completely barren.
Nothing there.
There is no ASP.NET package. There is no MySQL connector. There isn't even a reference to the Puppeteer engine that runs it.
The domain is entirely blind. It does not know an actor exists, and it certainly doesn't know about databases or web servers. Code with no I/O dependencies does not age. That domain logic could have been compiled 20 years ago, or it could be written tomorrow, and it would behave exactly the same way.
But if the domain is totally oblivious to the outside world, and the puppet refuses to make network calls, Who on earth is actually doing the dirty work? If I'm building this, something eventually has to write to the disk.
That underlying machinery is handled by the engine, what the audit refers to as the performance.
Okay.
The setup is incredibly lean. The hosting application builds one performance, it configures the I/O using a single configure storage command, and it starts it. That's it.
So the engine wraps the puppet. How does it handle multiple people trying to buy things at the same time? In the old world, you'd rely on database locks and transaction scopes to prevent race conditions.
The engine handles it through serialization. It feeds the actor one command at a time, sequentially. The serial line exists entirely within one identity.
To queue them up.
Exactly. Because it executes everything in memory, one after the other, it creates an island of consistency in a sea of concurrency. The domains don't need locks because the engine guarantees they only process one act at a time.
Here's where it gets really interesting. That fundamentally changes how we record history. In this puppet architecture, the system relies on the journal.
Yes, and the mechanics of this journal are crucial. When you look at a live run, the action is defined and recorded entirely once, along with its full body of logic.
Okay.
For any subsequent invocations of that action, the journal only stores the raw arguments. So for your second sale, the journal entry is basically just invoke action 1 with arguments 4000 and items 1, 2, 3.
Wait, so the act runs first, in memory,
Yeah.
and the system only journals the act after it has been fully constituted and validated.
That is the key mechanism. It is not writing a hopeful intention to a database on the way in, and it's not scraping data out of the domain to save on the way out. The act executes, the state updates in memory, and the constituted act itself is what gets journaled.
Okay, I have to play skeptic here again. Journaling actions, playing them back to rebuild state. This sounds exactly like event sourcing. Have we just reinvented event sourcing and given it a new name?
It is the most common comparison, but mechanically they are entirely different beasts. Think of it this way. Event sourcing is like keeping your grocery receipts. A receipt tells you exactly how your bank balance changed, the aftermath of an event.
Right, the ripple effect.
Exactly. This journal, however, is like a security camera at the register. It records the exact physical action the cashier took. One logs the ripple effects and state changes. The other logs the verb itself.
That makes total sense. It's logging the what was done with full authority. And because it's logging the verb, it completely changes how we handle failures. Let's look at the ultimate edge case. What happens if an authorization is rejected?
Right.
Say a customer tries to buy $4,000 worth of goods, but the bank only authorizes $3,000.
Think about the O1 before world. A rejection halfway through a transaction leaves a massive mess. You'd have inventory already marked as committed in the database, and you'd need a compensation bot or a complex rollback script to free that inventory.
And the domain would have written an HTTP 400 error to the log.
Right, but in the O2 Puppet world, we aren't touching a database during the logic phase.
So what happens?
The magic is in the non-occurrence. If the check phase rejects the authorization, absolutely nothing happens. If you watch the real console output in the audit, the stock was at 98 before the attempt. After the rejection, it stays at 98.
Wow.
The journal ID was at 4, and it stays at 4.
There is literally zero trace it ever happened. No rollbacks, no compensating transactions, no undo logic.
Because the act never finalized, it never entered history, a rejection is simply a non-occurrence. The domain state remains completely pristine.
It's incredibly clean. And this exact same philosophy extends to how the system outputs data. Let's talk about the boundary observer.
This is a great part of the audit.
Yeah, in the old monolith, if the business decided they needed to generate an XML invoice for a new tax authority, it was an architectural headache. The audit shows that adding that XML output costs 7 files, 3 brand new ones, and 4 heavily modified ones.
You even had to add a new enum inside the core domain just to name the tax authority.
Which means the core business logic had to be acutely aware of who was watching it. It was intimately tied to its audience.
But in the Puppet world, adding that exact same XML requirement costs exactly 1 single line of code at the boundary. The domain files remain completely untouched.
How does the system generate a complex XML document if the domain has 0 I/O and doesn't even know the tax authority exists?
It comes down to the separation of authority. The actor, the cashier puppet, decides what is observable. When the act finishes, it simply yields the raw values and facts of what just occurred.
Just hands over the raw data.
Exactly. But the boundary observer, sitting out in the engine layer, decides where that data goes and how it is formatted.
So the observer catches those raw facts, and it can do whatever it wants with them. which means one single print action from the puppet can generate two completely different documents simultaneously.
Absolutely.
The observer catches the data and writes invoice-1.txt with beautiful handcrafted formatting for the customer, and it also writes invoice-2.xml for the tax authority.
And the cashier never knew the tax authority existed. Changing the audience or changing the format of the receipt does not require you to change the underlying play.
Wait, if the puppet is blind to the outside world, and the boundary observer is just catching data to format it, where does the state actually live?
What do you mean?
Well, without a database, a cashier system is just a calculator that forgets everything when you turn it off. Where did the MySQL database go?
The database was relocated, and you could argue severely demoted.
Okay.
It no longer computes or rules the state of the business. It simply acts as a filing cabinet for history. If you inspect the raw rows in MySQL for this Puppet system, there are no complex relational tables tracking cart items or active inventory. It just stores the raw arguments of the channeled verbs. Action 1, arguments, 4,000 items 1, 2, 3.
It's just a dumb storage drive now.
That's all it needs to be. Because the engine rebuilds the in-memory state from those verbs when it spins up, and choosing between a simple text file on a local drive or a massive clustered MySQL database is literally just changing one argument in that configure storage setup method.
You don't have to rewrite your repositories.
Zero code changes required in the business logic. How you store a journal is a matter of operational convenience, not a matter of software architecture.
If we pull back and look at the bigger picture, all of these mechanics, the journal, the blind puppet, the boundary observers, they all drive home this grand thesis we found in Section 15 of the audit.
Section 15 states it perfectly. Programs are staged, domains are not. A domain is written once everything else is a staging.
I want that framed on my wall. Once you treat the domain as having its own pure mathematical identity, independent of how it gets deployed to the cloud, all your infrastructure just becomes a temporary stage for the actors to perform on.
It really shifts your perspective.
Let's look at the final scoreboard for this transformation because the numbers are undeniable. We started with 22 files in the domain project. That plummeted to 5.
We had 6 complex interfaces dedicated to dependency injection. That dropped to 0. There was nothing left to invert.
The fatal dependency cycle between sales and warehouse. It wasn't solved by adding more abstraction layers or microservices. It died simply by fixing the vocabulary and putting an author in the middle.
And remember, a rejected bank authorization used to leave phantom stock in a database and throw domain errors. Now it leaves absolutely nothing. It is a non-occurrence.
Adding a new tax XML output went from a 7-file refactor to a 1-line addition at the boundary. And the database was demoted from the source of truth to a simple filing cabinet for verbs.
It is a comprehensive structural transformation, and it begs a fascinating question for you listening. If business logic no longer needs to be tangled with infrastructure, and domains are entirely blind to their deployment, what is the future of our profession?
That's a big question.
Will the developer of the future even need to know how to write a complex database query? Or will writing software look much more like writing a screenplay? Directing actors, defining verbs, and letting the engine handle the rest.
That is a phenomenal paradigm to ponder. It completely reframes what we do all day. And it leaves you with a very practical test for your own work. Go look at your code base right now. Can you point to the single artifact that fully constitutes an act?
The one place where a complete business decision becomes one named atomic thing.
Does it even exist? Or is it scattered across 5 different services and database triggers?
If you can't name the act, you are probably dealing with an orchestrator trying to wrangle chaos.
Exactly. If your code feels like that living room sofa with the plumbing sewn into the cushions where pulling on a warehouse requirement breaks a sales database, it is time to rethink the layout.
Definitely.
And the best part is you do not have to take our word for it. The code from this technical audit is public. Go clone it. Trigger that MSB 4006 build error for yourself, put a breakpoint in the engine, and watch a rejection leave absolutely no trace in the journal. Draw your own conclusions. That is our deep dive for today. Thanks for exploring the architecture with us, and we'll catch you on the next one.